And if you crank through that math,
Wouldn't it cancel off the meter squared and kilograms squared? So you would
it
just
should be left with newtons.
Exactly.
Is the 3 meters supposed to be 9 meters or 3 meters squared?
3 meters is squared, so you
Okay.
end up with a 9 on the bottom.
Okay.
Oh.
5. So I have 5.14. The 8 is repeating. Times 10 to the 8 to the negative 8 power.
Units?
Is it just G?
No.
Not sure.
What do we find?
Newtons.
Yeah, newtons. We found a force. So when we talk about all those little forces, the gravitational pull between me and the Earth is around 1,000 newtons. Between me and probably a heavier lower than reality is on the order of 51 billionths of a newton, which is why we ignore those forces when we were dealing with force diagrams. We have no equipment here that can measure forces this small. Wake Forest has some. Actually, I don't know if it's that small. What'd you get?
I mean, it's kind of the same. It's 5.154 with the 3 after that's repeating, correct?
That's what I got too.
Times 10 to the negative 8.
Yeah,
Oh,
that's
I
what
forgot
got.
the 7. Yeah.
All right. I probably would not notice on the quiz test. So it's an incredibly tiny force. So the reason that we're going to deal with it, though, if we're dealing with planetary motion. So, for instance, the moon. I keep picking them up and putting them down somewhere. Earth, moon. I know that the moon is close enough to a circular orbit around the Earth. With the purist, yes, it's elliptical, close enough to a circle. What is the force that keeps the moon going around the Earth?
Gravity.
Gravitational force.
Thank you. The moon is pulling on the Earth, which we notice in the form of changes in tides. The direction of acceleration of the moon?
Towards the Earth.
Yes. So we've set up my coordinate system as such. My acceleration is towards the Earth, so I'm just going to make towards the Earth positive. Set up my, I don't have to decompose anything because I got one force. Plug it into my equation of motion, so I have the force is equal to the mass of the moon times the centripetal acceleration.
But did you say the forces come from Earth?
Yes. The moon is pulling, the Earth's pulling on the moon and the moon's pulling on the Earth. So the Earth should wobble just a little bit. But because the mass of the Earth is so much bigger than the mass of the moon, we don't notice it really, except for tides. So then we plug in substitution. I got a formula for the generalized force of gravity, mass of Earth, mass of moon, over the orbital radius of the moon, ME for moon, Earth radius, orbital radius, times mass of moon, because we're looking at the forces acting on the moon, times V squared over R. And that R is the distance it's the orbital radius. Notice that the mass of the moon cancels out.
What does R squared?
What, there?
Yeah,
ME for moon, earth.
okay.
What are they saying for R?
Yep. So that R can cancel out with one of those. So the speed of the moon depends upon this constant times the mass of the earth, which is relatively constant, divided by the orbital radius. We can take it one step further. I know the speed is 2 pi r over the period squared. I can actually find the mass of Earth doing this. All I need to know is what is the orbital radius of the moon, which we can figure out. Just stand on 2 points on the Earth, look at it up at the sun, do a little triangulation, say we're out in a big field and we have really good equipment. I look to see what that angle right there. I look at that angle right there. I know, if I know that distance, I can calculate how far away the distant object is. Obviously, when you're dealing with the moon, it gets more complicated than that, but that's the essence of it. So I can find this distance here, period. Well, what is the period for the moon to go around the Earth?
24
4
hours.
hours. No, that's the.
24 hours is how often we see it.
Is it like 1 month because
Yeah.
of the last minute?
Yeah,
Oh,
it's
yeah.
roughly 28 days. So we know what the period is. So we know G, R, we can somehow figure out. In essence, at this point, we would look it up and we can find the mass of the Earth. Or if we know the mass of the Earth, we can figure out what R is, et cetera, et cetera. But that's fine. Master set 6, I'm not going to require to be handed in, but if you work on master set 6 and want the answers, just ask me.
Or could it be extra credit?
Could it be extra credit?
Sure.
Yay!
The way the extra credit works is if it helps you, I count it. If it doesn't help you, I don't count it. So if you do half of it, that probably is not gonna help you.
Okay.
Okay. I'm not so good.
He said if you just turn master set 6 and
Have you
it
done
doesn't,
some
I don't
master
think
set
you
this
didn't set a due date, so.
On the first two, did you say like the forces of time each other would be equal? Here's what I wrote in mine. Because it's
Yes.
two, the first one are two, one big part, one small part. And then,
I think that's what I put for mine.
I'm gonna ask them real quick before I leave.
I got some salary.
Yes.
And then.
Yes. So let's talk about,
Yeah, because it,
I mean,
yeah.
lectures are posted and
It's a
the links
bit
should be
And then for
online.
the, I know the jumping, I just don't know if I did that.
How far behind
You're
are
right.
you?
Oh,
Are you able to do it?
Like, I know when you jump, you put a negative pressure, you put negative force, no, positive force on the
Okay.
ground. And then the force, the ground gives you negative.
Will I be excused from
So,
that?
when
'Cause I can't imagine I can really.
we're jumping up,
Yeah, you got.
velocity is positive,
yeah.
acceleration is still negative.
No, just
Yeah, I can make
force
those
is
good.
positive
The test
when
is
you're
my only
jumping up.
concern.
From the
Yes.
ground to the negative.
And normal force is
So-
in relation to,
Yeah,
acceleration.
yeah.
I think you're right about that.
I think I was gonna write down the end of this one.
This is so much to
I didn't really